In today's video, we'll be discussing about Physics Paper 1, MCQ Paper 2024, February-March, Variant is 12, and the subject code is 9702. Question number 1. Which row shows the physical quantity and its base unit in the SI system? So, physical quantity, there are 7 base physical quantity or there are 7 base quantity that are time, length, mass, current, temperature, amount of substance, and luminance intensity. So, current, mass, and temperature. The SI unit of current is ampere, the SI unit of mass is kg, not gram, and the SI unit of temperature is Kelvin, not degree centigrade. So the correct statement is A. That is, the current and its SI unit is ampere. Question number 2. A car of mass 850 kg is traveling in a horizontal straight line. The diagram shows the two horizontal forces acting on the car in opposite directions. That is, 1600 Newton in opposite direction and 1200 Newton in the direction that the car is traveling. What is the magnitude of acceleration of the car? So for the magnitude of acceleration, we know that resultant force is equal to mass into acceleration, and the resultant force is the forward force. That is, the forward force minus backward force is equal to mass into acceleration. So the acceleration comes to be negative 0.47 meter per second square, but here it mentions about the magnitude and not the direction. So the magnitude is 0.47. That is option A. Question number 3. An object of mass m is suspended by a spring from a fixed point. The spring has a spring constant k. So spring constant is the force per unit extension. The object is set in vertical oscillations of period t. Which equation for t is homogeneous with respect to base unit? So homogeneous with respect to base unit means that the left hand side is equal to right hand side. For example, if the left hand side is meter, then the right hand side also have to be meter. If the left hand side is Kelvin, then the right hand side have to be Kelvin. And all of these options need some working, and the correct statement is D, because in on the left hand side there is T, which is the time period, and the SI unit of time period is second. So we need to make the right hand side second. So the right hand side is second in this option. So 2 pi has no unit and root over m by k. So the SI unit of mass is kg, and for k, that is the spring constant. Spring constant is force per unit extension. Force is equal to mass into acceleration per unit extension. So mass is equal to kg meter per second square per unit extension, and the SI unit of extension is meter. Since extension is a length, so its unit is meter. So after cancelling the meter, we get kg per second square. So kg per second square and kg cancels. So root over second square is second. So here we can see that the left hand side, that is the second, is equal to the right hand side second. Therefore the equation is homogeneous. Number 4. An object of fixed mass is initially at rest at point P. So the object has a fixed mass. The object then moves away from point P with uniform acceleration. Which statement describes the resultant force acting on the object when it is moving? So the mass is fixed mass and the acceleration is uniform. That means the acceleration is not changing. Since the mass is fixed and the acceleration is not changing, so the resultant force have to be constant. So it increases uniformly with respect to time. So since acceleration is not changing and acceleration is uniform and the mass is also constant, therefore the resultant force have to be constant. It is constant but not zero. Yes, the mass is constant and the acceleration is uniform, so the resultant force have to be constant. So it is constant but not zero. So the more appropriate answer is B. Number 5. A projectile is launched at an angle of 25 degrees to the horizontal with the horizontal component of velocity is 13. So 13 meter per second. So the projectile is launched at an angle of 25 degrees to the horizontal, and this is the velocity of the projectile, and it is given that the horizontal component of velocity is 13. So if we divide this velocity into its component, so the horizontal component and the vertical component, so the horizontal component becomes v cos 25, that is v cos 25, and the vertical component becomes v sin 25. And it is given that the horizontal component is 13, so the horizontal component is equal to 13. What is the vertical component of velocity of the projectile when it is launched? So we need to find the vertical component of velocity, that is this component. So to find this value, we know the value of sin 25, but we need to find the value of v. So what is the value of v? Initially we have given the horizontal component of velocity, so we can equate this equation to find the value of v. So we know the value of v, then we can substitute the value of v in the vertical component of velocity equation to find the vertical component of velocity, that is 6.06, that is approximately 6.1 meter per second. So the answer is B. Question number 6. What is the total displacement of the ball from its original position x at 1.5 second? So from its original position to 1.5 second, what is the overall displacement or the total displacement? So area under the velocity time graph gives us displacement. So area under the velocity time graph gives us displacement. So what is the total displacement? Total displacement is the positive displacement minus the negative displacement. So what is the positive displacement? So it is a triangle. So half into base into height. So half, base is 1 and the height is 10. So half into base into height minus the negative displacement. So half into base is 1.5 minus 1, that is 0.5, and the height is 5. So after subtracting, we get the overall displacement as 3.75 meter. So that is option B. Question number 7. What is the definition of acceleration? So acceleration is the rate of change in velocity or the change in velocity per unit time. So change in velocity per unit time or the rate of change in velocity. So the rate of change in velocity, this is not per unit time, this is just the rate of change in velocity. So the acceleration would be rate of change in velocity or the change in velocity per unit time. So the answer is A. Number 8. Two balls P and Q of equal mass move along a straight line directly towards each other as shown. So P and Q are moving directly towards each other. Ball P has a velocity of 1.3 meter per second to the right, so 1.3 meter per second to the right, and ball Q has a velocity of 0.5 meter per second to the left. So 0.5 meter per second to the left. P and Q collide with one another. The collision is perfectly elastic and the total momentum is conserved. So the total momentum is conserved, and since the collision is perfectly elastic, so for perfectly elastic collision, kinetic energy is conserved and the relative speed of approach is equal to relative speed of separation. So you have to remember that for perfectly elastic collision, kinetic energy is conserved and the relative speed of approach is equal to relative speed of separation, and this is the equation, that is for the relative speed of approach is equal to relative speed of separation, that is u1 v1 is equal to u2 v2. So which diagram correctly shows the motion of P and Q after collision? So which diagram correctly shows the motion of P and Q after collision? So we need to find the motion of P and Q. First of all, so we know the value of u1, that is the velocity of P, that is 1.3, so 1.3, and u2, that is the velocity of Q, that is 0.5. So u2 is 0.5, but since it is mentioning about velocity and we take the direction towards the right as positive, so the velocity of Q is in opposite direction, so it is negative value. So after arranging this, we get v2 minus v1 is equal to 1.8. So whichever equation that gives the v2, that is the velocity of Q, minus the velocity of P as 1.8, it would be the correct answer. So for option A, both are moving to the right. So 0.58, that is v2 minus v1. So 0.22 gives us a value, that is 0.36. So 0.36 is not the answer because the difference is 1.8. Then 0.4 minus 0.4 gives us a value of 0. Therefore, this is also wrong. Then for option C, so Q is moving to the right. So right is positive. So 0.99 minus, and P is moving to the left. So the left, since it is moving to the left, so the velocity is negative. That is minus in bracket negative 0.19. So 0.19. So 0.99 minus 0.99 minus in bracket negative 0.19 gives us a value, that is 1.18. So 1.18. So this is 1.8, not 1.18. Therefore, this is wrong. Then option D. So Q is moving to the right. So 1.3 minus. So V2 minus V1. So V1 is moving to the left. Therefore, it is negative. So 0.5. So after calculating, we get a value that is 1.8. So the correct statement is D. Question number 9. A basketball player hits a ball vertically downwards. So he hits a ball vertically downwards with a speed of 2.4 meter per second So initially it has a speed of 2.4 meter per second from a height of 0.9 meter. The air resistance is negligible. What is the speed of the ball as it hits the ground? So we need to find the speed as it hits the ground. So we know the initial speed, we know the height. So we know the initial speed, we know the height, and we need to find the final speed. And also we know the value of acceleration, that is 9.81. So v square minus u square is equal to as. So v square is equal to u square plus 2as. We know the value of u, and we know the value of acceleration, that is 9.81, and s is 0.9. So after calculating we get a value of 4.8 meter per second, that is option B. Number 10. A ball falls through a liquid at a constant speed. So the speed is constant. It is acted upon by three forces: upthrust, a drag force, and its weight. The liquid has a uniform density. So the density of the liquid is uniform. Which statement is correct? So this is our ball, and as the ball is falling, it has a weight that is acting vertically downward, and upthrust is obviously acting vertically upward. So this is the upthrust, and the drag force is acting upward. Since the object is moving downward, so the drag force is acting upward. So this is the case. And for upthrust is equal to rho Vg, where rho is the density of the liquid, rho is the density of the liquid, V is the volume of the object. So V is the volume of the object, and G is the gravitational field strength. And the volume of the object is constant, the density of the liquid is constant, and the gravitational field strength, that is 9.81, is constant. Therefore upthrust is also constant. So upthrust is constant, weight is constant, and the weight is acting downward. So weight is the downward force, while upthrust and the drag force are both acting upward. So downward force is equal to upward force. And why the forces are equal? Because the object is moving at a constant speed. Since the object is moving at a constant speed, so there is no acceleration. That is, resultant force is equal to mass into acceleration. So the speed is constant, therefore acceleration is 0. Therefore the resultant force is 0. And since the resultant force is 0, so the upward force is equal to the downward force. That is, weight is equal to upthrust plus drag force. So which statement is correct? The drag force increases with increasing depth. This statement is wrong because the drag force or the air resistive force mainly depends on speed. Since speed is constant, therefore the drag force is also constant. The drag force is equal to the sum of the upthrust plus weight. This is wrong because weight is equal to sum of upthrust plus drag force. The upthrust is constant with increasing depth. So here I have mentioned that the upthrust is constant. There is upthrust is equal to rho Vg, where rho is the density of the liquid, V is the volume of the object, and G is the gravitational field strength. Therefore the upthrust is constant. So upthrust is constant with increasing depth. Therefore the correct statement is C. Then weight is greater than the sum of drag force and upthrust. So weight is equal to the sum of upthrust plus drag force. So it is not greater, this is equal to. Therefore this option is wrong. So the correct statement is C. Number 11. Some small solid cubes each have a mass of 1 kg and sides of length 5 cm. The small cubes are stacked together, so they are stacked together to form a large solid cube with sides of length 2 meter. So large cube has a side of 2 meter and the small cubes has a side of 5 cm. What is the weight of the large cube? So we need to find the weight of the large cube. So if we use the length to compare these two values, then since 2 is in meter, so we need to convert the 5 cm to meter, that is 0.05 meter. So 0.05 meter is equal to 1 kg. So 2 meter is equal to 1 by 0.05 into 2, that is approximately 40 kg. So 40 kg, and if we convert this to Newton, that is weight is equal to mass into gravitational field strength, that is 9.81, we get a value of 392 Newton. And if we see the options, we does not have this value. Therefore, we cannot use length to compare this weight, to compare this mass. But since it is a cube, so its volume would be length cube. That is, all the sides are same for a cube. Since it is a three-dimensional object, so the volume would be length cube. That is 0.05 cube. But if we use a volume to compare the masses, then 0.05 cube is equal to 1 kg. So 2 cube is equal to 1 by 0.05 cube into 2 cube gives us a value that is 64,000 kg. And if we compare the, and if we convert this to weight, then weight is equal to mass into gravitational friction, that is 64000 into 9.81 gives us a value that is 6.27 into 10 to the power 5, and all of these are given into one decimal place, so 0.627 into 10 to the power 6. So 10 to the power 6 is mega, so mega and 0.63, so 0.63 mega Newton. So by using the volume, we have compared the masses, then after comparing the masses, we find the weight. So by using the volume, we get the weight, that is 0.63 meganewton. That is option C. Question number 12. A borehole of depth 2000 meter contains both oil and water as shown. The pressure due to the liquid at the bottom of the borehole is 17.5 megapascal, that is 10 to the power 6 pascal. The density of the oil is 830 kg per meter cube and the density of the water is 1000 kg per meter cube. What is depth x of the oil? So we need to find x. There is this depth x. So first of all, what is the pressure that is given? That is 17.5 megapascal. So this pressure is the pressure of the oil plus pressure of the water. That is the total pressure acting at the bottom is the pressure of the oil plus pressure of the water. So, and we know that pressure due to liquid is pressure is equal to rho gh. That is, pressure is equal to rho gh, and the pressure at the bottom, that is 17.5 into 10 to the power 6 pascal, is the pressure due to the water and pressure due to the oil. So what is the pressure due to the oil? Pressure is equal to density of the oil into gravitational friction and the height, that is x. And what is the pressure due to water? Pressure is equal to density of water into gravitational friction, and what is this height? This height is 2000, that is the total height, minus x. So 2000 minus x, that is 2000 minus x. So after rearranging and calculating this, after rearranging and calculating the value, we get a value of x, that is 1271.2, that is approximately 1270 meter. So the option is D. Question number 13. A rod is pivoted at one end. So the rod is pivoted at one end, that is at this end. Initially the angle theta of the rod to the horizontal is 0. That means in respective to the horizontal, the angle of the rod is 0, that is at 0 degree. The weight of the rod causes a moment m about the pivot. So the weight of the rod that is obviously acting at the center causes a moment m about the pivot. And what is the moment? We know that moment of force is the product of force and the perpendicular distance from the pivot to the line of action of force. That means basically the moment of force is the product of perpendicular force and the distance from the pivot. So the force have to be perpendicular force with respective to the pivot. So the force have to be perpendicular with respective to the pivot. Then the rod is then rotated in the vertical plane so that the angle theta of the rod increases from 0 degree to 180 degree, which graph shows the variation of moment with theta. So we need to find which graph is the moment against theta. So at 0 degree, we can see that with respective to the pivot, the force is perpendicular. So, and there is some distance. So obviously there is some moment. Then at 180 degree, that means at 90 degree, when the rod is at 90 degree with respective to the horizontal, when the rod is 90 degree, the weight is acting vertically downwards. And here we can see that with respective to the pivot, the force is not perpendicular, the force is parallel. With respective to the pivot, the force is parallel. Therefore, the moment is 0. Since there is no perpendicular force, therefore the moment is 0. That is, moment is 0, moment 0 and moment 0. There is no 0. Therefore, this option is wrong. Then, when at 180 degree, that means the rod is at the other end, we can see that there is a perpendicular force with respective to the pivot. There is a perpendicular force and obviously there is some distance from the pivot. Therefore, there is some moment. So, in all of these three options, there is some moment. But we need to find that which option is correct. So, initially at 0 degree, if we see, then with respective to the pivot, the weight is acting downwards. So, there is a clockwise moment. And at 180 degree, with respective to the pivot, with the weight is acting downward, so there is an anti-clockwise moment. So the clockwise moment, if we consider the clockwise moment as positive, then the anti-clockwise moment must have to be negative. So the anti-clockwise moment is negative. Therefore, the option should be either C or D. This is not B. then the anticlockwise moment is negative, then whether the option should be C or D. So first of all, if we consider the angle of 45 degree, that means the rod is at an angle of 45 degree, then the weight is acting vertically downward, and if we break the weight into its component, that is the vertical and the horizontal component, then this component is W cos 45 and the horizontal component is W sin 45. And what is the moment? So moment of force is the product of force and the perpendicular distance from pivot to the line of action of force. So the force have to be perpendicular. Therefore, we have to consider the perpendicular force with respect to the pivot. So the perpendicular force is W cos 45. So W cos 45. So this is the moment that comes. So here we can see that this is the cos graph. So cos graph is not a straight line. This is not a linear graph. This have to be curved. So the option should be D. And so the option is D. But for the cos graph and sine graph, you must have to remember that the cos graph, instead of starting from 0, it starts from a higher value. That is, if we press cos 0, it gives a value of 1, that is a higher value. But the sine graph always starts from 0, that is, if you place a sine 0 at the calculator, then it gives us a value of 0. That means the sine graph always starts from 0, but the cos graph starts from a higher value. So this is the case. In question number 14, a hinge trapdoor is held close to horizontal position by cable. So the door is horizontal. Which list gives the three forces in increasing order of magnitude. So these three forces are acting on the door. So as the door is horizontal, so the upward force is equal to the downward force. Since the upward force is equal to the downward force, that means this upward force must have a higher value because it is equal to the two downward forces, that is this value and this value. So obviously T have to be a higher value. That is T have to be a higher value. And so the higher value is in option C. So the answer is C. Number 15. What is the definition of force? So force is the product of mass into acceleration. Also, the force is equal to rate of change in momentum. So when you have asked to write the definition, you have to choose the rate of change in momentum. So the correct statement would be C. Question number 16. A boat moves at a constant velocity v through still water. A constant drag force F acts on the boat. What is the power used by the boat to move through the water? So we know that power is equal to force into velocity. So power is equal to force into velocity. That's why the option is B. Question number 17. The diagram shows four forces acting on a circular disc. Each force has a magnitude F. Two of the forces act vertically and the other two forces act horizontally. So two forces are acting vertically and two forces are acting horizontally. All four forces act in the same plane as the disc. No other forces act on the disc. The disc has a diameter d. So the diameter is d. Which statement is correct? So all of this statement mentions about equilibrium. So for an object to be in equilibrium, the resultant force is 0 and the resultant moment have to be 0. So here we can see that the resultant force, that is upward force, is equal to downward force and the force on the right is equal to the force on the left. So the resultant force is 0. But what is about the resultant moment or the resultant torque? So we know that for the moment of force, for this condition, the forces are the same. So the moment of force is the product of force and the distance between the two forces, that is T. So moment of force is the product of force and the distance between the forces. Similarly, the product of force and the distance between the two forces, that is D. That is Fd. So moment comes to be 2Fd. So the moment is 2Fd, that the resultant torque is 2Fd, and since there is a resultant moment, so the object is not in equilibrium. So not in equilibrium. Question number 18. A ball is projected into the air from the horizontal ground and follows the path shown in the diagram. So the ball moves from this way to upwards and then downwards. So at the topmost point, the kinetic energy is 0 and it has only a gravitational potential energy, and initially the vertical height is 0, so it has only kinetic energy. At point QRST, the ball has kinetic energy AQ, ER, ES and ET respectively. The height above the ground of these 4 points are shown. So the height above the 4 points are shown that is the height above the ground. Air resistance is negligible. So the air resistance is negligible. Which difference in kinetic energy is the smallest? So initially it has some kinetic energy, but at the topmost point, the speed is 0. So kinetic energy is 0, and it has gravitational potential energy. So gravitational potential energy is mass into gravitational field strength into height, and kinetic energy is half mv square. And at any of this point, it has gravitational potential energy as well as kinetic energy. So the points that has less difference in height also have a less difference in kinetic energy. So here we can see that the difference between these 2 points is 0.3. Then R and S, the difference is 0.2, and S and T, the difference is 0.3, while for the less difference, that is 1.5 and 1.6, if we compare the difference in height, then the difference is 0.1. So since it has less difference in height, so it must have a less difference in kinetic energy, that is point Q and point S. So Q and S. Therefore, the answer is A. Question number 19. The battery of a small tablet computer is initially uncharged. So the battery is uncharged. The battery is uncharged. It is connected to a constant 10-watt power supply for 2 hours to charge the battery. So the battery is then charged. The efficiency of the charging process is 80%. What is the total energy stored in the battery? That means the energy stored in the battery is the energy after charged. So what is the total energy stored in the battery? So to find the energy, we know that energy is equal to, so power is equal to voltage into current, and energy is equal to power into time. So energy is equal to power into time, and we have given the energy that is, and we have given the power that is 10 watt. So power and time, we must convert the time to second. This is 2 hour into 60 minute into 60 second. So this is the total energy, and this energy is the energy that is being provided. So this energy is being provided, therefore it is the initial energy. And after the energy is stored in the battery, the charging process is 80%. That means 80% of the energy is stored in the battery. So what is the 80% of the energy stored in the battery? So 80% is this much energy. So this much energy is stored in the battery. That is 5.76 into 10 to the power 4. That is approximately 5.8 into 10 to the power 4. That is, this energy is stored in the battery after the charging process. Question number 20. An initially stationary firework explodes and splits into 2 fragments. So it splits into 2 fragments that move horizontally in opposite directions. The total kinetic energy transferred to the fragments by the explosion is E. That is, the total energy is transferred to the fragment is E. One fragment has a mass of m, that is, one fragment has a mass of m, and the other fragment has a mass of 2m. So other has a mass of 2m. What is the speed of the fragment of mass m initially after explosion? So what is the speed of the fragment of mass m, that is this fragment, after the explosion? So both the fragments are moving in opposite direction, that is in opposite direction, and you must have to remember that the momentum is always conserved. Since the momentum is always conserved and momentum is mass into velocity, so since it has a mass of m, so and it has a mass of 2m, since it has a mass of 2m, so it has a velocity of v, while this has a mass of m, so it must have a velocity of 2v. So 2v into m, and 2m, that is 2m into v. So the momentum on the right is equal to the momentum on the left, that is, the momentum is always conserved. So for the mass m, it has a velocity of 2v, and for the mass of 2m, it must have a velocity of v. So what is the speed of the fragment m? And so the total kinetic energy is E. So the total kinetic energy is E, and we know that kinetic energy is half mv square. So half m and 2v square plus half 2m into v square is the total energy, that is the total energy transferred to the fragments. So the total kinetic energy transferred to the fragments. So we equate this and find the value of v, that is v is equal to root over e by 3m. So root over e by 3m. So v is the root over e by 3m. But we need to find the speed of the fragment of mass m. So fragment of mass m has a speed of 2v. So for v, we get this value. For 2v, so for 2v, we must have a value of 2 root over e by 3m. So 2 root over E by 3m, or you can say that 2 root over E by 3m is equal to root over 4E by 3m, that is root over 4 is 2, so this is the same. Therefore the option is D, that is exactly same as the given option. Number 21. The spring is fixed at one end and extended by applying force F to the other end. The spring has extension X and the elastic potential energy is AP. The spring constant is K. The spring obeys Hooke's law. Since the spring obeys Hooke's law, that means force is directly proportional to extension. So force is directly proportional to extension. Which relationship is correct? So for spring constant, we know that spring constant. So for elastic potential energy, we know that elastic potential energy is half Fx or half kx square. So half Fx or half kx square. So which relationship is the correct? So here we can see that the force is changing. So force is changing, and so we cannot relate exactly elastic potential energy with extension. But here we can see that half is constant, spring constant. Since spring constant is constant, so it is a constant value. That means elastic potential energy directly depends on the extension square. So elastic potential energy is directly proportional to extension square, and the other things are constant. Therefore, the option is correct is D. 22. A force extension graph is produced for a metal wire. What must describe the limit of proportionality of the wire? So for the force extension graph, the limit of proportionality is the point at which the graph starts to become non-linear. That means initially it is a linear or a straight line graph, that is Hooke's law is obeyed, that is force is directly proportional to extension. So after limit of proportionality, the graph starts to become non-linear. The point beyond which Hooke's law is not obeyed. So limit of proportionality is the point beyond which Hooke's law is not obeyed and the graph starts to become non-linear. So this is the definition for limit of proportionality. And let's suppose this is the elastic limit, and the elastic limit is the point after which the graph starts to deform or the wire starts to deform plastically. That means beyond the elastic limit, the wire deforms elastically, but after the elastic limit, the wire deforms plastically, and from the elastic limit, the wire can return to its original position. So, for this option, the limit of proportionality answer is B. 3. A spring has a spring constant of 6 Newton per centimeter, 6 Newton per centimeter, is joined to another spring whose spring constant is 4 Newton per centimeter. 4 Newton per centimeter, a load of 80 Newton is suspended from the composite spring. So the load is 80 Newton. What is the extension of the composite spring? So what is the total extension? So total extension is the extension of this wire, that is the extension of this wire plus the extension of this wire. This is the total extension, and this load is experienced by both the wires. So we know that spring constant is equal to force per unit extension. So spring constant is equal to force per unit extension, or extension is equal to force by spring constant. So extension is equal to force by spring constant. Since this force is experienced by both the wires, so the force is thus same, that is 80 by the spring constant of the first wire, and this is the extension of the first wire, and for the extension of the second wire, extension of the second wire is equal to force by the spring constant of the second wire. So this is the extension of the second wire. So the total extension is the first extension plus the second extension, that is the total extension, it comes to be 33.33 centimeter, that is approximately 33 centimeter. Question number 24. The range of frequency of sound waves emitted by blue whales is 10 Hz to 40 Hz. The speed of the sound in seawater is approximately 1.5 km per second. So first of all, we need to convert the speed to meter per second. So 1.5 km per second. So kilometer to meter, that means we need to multiply this with 1000. So kilometer to meter, it comes to be 1500 meter per second. So we know the value of V and we know the frequency. What is the approximate range of wavelength, that is lambda, of the sound emitted by the blue whales? So V is equal to F lambda, lambda is equal to V by F. So V is the same, that is V is the same, and here we have given the two frequency. So for this two frequency, we find both the wavelength, that is 150 and 37.8. So 150 and 37.8, or approximately 38, meter. So the unit is meter. So the answer is T. Question number 25. A sound wave is detected by a microphone and displayed on the screen of the CRO. The frequency of the wave is 2.5 kHz. So we have given the frequency that is 2.5 kHz, or kilo is 10 to the power 3. So 2.5 into 10 to the power 3 Hz. So we know the value of frequency. What is the setting on the time base of the CRO? So the time base means that the time for one box. So to find the time for one box, so first of all we need to find the time period, that is the total time taken to complete an wave. So frequency is 1 by time period. So 1 by time period is equal to the frequency. So time is equal to this value, that is the time period is equal to this value. So we know the value of time period, that is the time taken to one complete wave, that is this wave. And this wave, to complete this wave, it completes 1, 2, 3, 4. So 4 boxes. So 4 box is equal to this value, that is the time period. So 4 boxes is equal to this value. So what is the time base for one box? So for one box is this value by 4. So this value is for one box, that is the time base. So what is the time base? Time base is 1 into the power 84. So all are given to decimal places, that is one decimal place. So 0.1 into 10 to the power negative 3. So 0.1 into 10 to the power negative 3, that is millisecond. So the answer is A. Number 26. A source of sound with constant frequency moves towards a stationary observer. The observer compares the sound wave arriving at the observer's position with the wave emitted by the source of sound, what is detected by the observer. So as the object moves towards the observer, so we know the equation, that is F0 is equal to FSV, V plus minus Vs. And for the object moving towards the observer, it would be a minus Vs. And for the object moving away from the observer, it would be plus Vs. So since it is moving towards the observer, so V minus Vs. And since where we can see that the V minus Vs, the denominator is less. So the denominator is less, that means the observed frequency is more. Since the observed frequency is more, so frequency is more and phase is equal to f lambda, so frequency is more, that means the wavelength is less. So since frequency is more, the wavelength is less. So a decreased wavelength of sound observed, that is the observer hears a decreased wavelength of sound. So the wavelength is decreased because the frequency is more. Number 27. Which type of waves cannot be polarized? So transverse wave can be polarized, while longitudinal wave cannot be polarized. So radio waves, ultraviolet and X-ray, these are all transverse wave, so that can be polarized. While sound wave is a longitudinal wave, therefore it is not polarized. Question number 28. A beam of light with power P has an area of cross-section A. The amplitude of the light waves in the beam is X. The beam of light is changed to 1 with the same frequency but with an amplitude of 4x, and an area of cross-section is reduced to A by 3. What is the power of the new beam? So we need to find the power of the new beam. So first of all, you must have to remember the two equation, that is intensity is equal to power divided by area, and intensity is directly proportional to amplitude square. So intensity is power per unit area and intensity is directly proportional to amplitude square. So for the first case, we have given the value of power, that is P, and the area, that is A. So power and area, that is A, and here we have given the amplitude, that is X. So amplitude is X, that means intensity is directly proportional to X square. X square. So intensity is directly proportional to X square. That means if the intensity is I, then the amplitude is X square. So power is equal to X square A. That is for the first case. Then for the second case, here we have given the amplitude, that is 4x. So from this equation, intensity is 4x square. So 4x square whole square, and the area is A by 3. So A by 3, what is the new power? So by using this equation, what is the new power? It comes to be 5.33 x squared A, and x squared A is same as x squared A, and x squared A is power. So 5.33 P, that is 5.3 P, that is B. Time. Two loudspeakers are connected to the same signal generator. The signal generator produces a single frequency. The loudspeakers face each other so that a stationary sound wave is set up in the region between the loudspeakers. So between the two loudspeakers there is stationary wave is produced. A microphone is connected to the cathode ray oscilloscope and positioned between the two loudspeakers. So the microphone is placed between the two loudspeakers. The microphone is moved along a line joining the two loudspeakers. So the microphone is moved along the two loudspeakers or in between the two loudspeakers. The signal on the CRO shows 5 maximum amplitudes, that is 5 maximum amplitudes or 5 antinodes as the microphone moves. Since it is a wave, stationary wave, so node and antinode are produced. An antinode gives a maximum amplitude while node gives a minimum amplitude. The microphone moves a distance of 2 meters from the position that gives the first maximum to the position that gives the fifth maximum. So first maximum, then second, third, fourth, fifth. So first maximum to fifth maximum. That is the first antinode to fifth antinode. And for a stationary wave, if we see a stationary wave, then this is the stationary wave. And for the stationary wave, the distance from one antinode to another antinode is half the wavelength. That is from one antinode to another antinode and then to another antinode. So this is one complete wave. So the distance from one antinode to the next antinode is half the wavelength. So half the wavelength. That is from one antinode to another antinode is half the wavelength, and from one antinode to another and then another is one wavelength. That is this one wavelength. So this is one wavelength. That from first to the third antinode is one wavelength. So first to third is one wavelength. Then from third to fifth is one wavelength. So in total, 2 lambdas are completed and the distance is 2 meter. So 2 lambdas are completed in a distance of 2 meter. So 1 lambda is completed in 2 by 2, that is 1 meter. So wavelength is 1 meter. Number 13. Two wave sources emit coherent waves. Which condition must be correct for coherent waves? So coherent waves means that they have a constant phase difference. So coherent means that they have a constant phase difference. So the waves have a constant phase difference. This is actually the definition of coherent, that is the constant phase difference. So coherent wave means that the waves have a constant phase difference. So the answer is C. In question number 31, a student sets up an experiment to investigate the double slit interference. The student uses light of single wavelength from the laser to illuminate on a double slit so that a pattern of interference fringes is observed on the screen. So for the double slit experiment, we know the expression that is x is equal to lambda d by a. X is equal to lambda d by a. So x is the fringe separation, that is the fringe separation, and lambda is the wavelength, d is this gap, that is q. So d is referred as q, and a is the slit separation, so a is referred as r. So x is equal to lambda q by r. That is in terms of this given diagram. The student finds the fringes that are very close together. So fringes are very close together, that means x is together. Thus, what could the student decrease? So what could the student decrease in order to increase the separation of fringes on the screen? So to increase the separation of fringes on the screen, that means we need to increase the separation of the fringes on the screen. That means we need to increase the value of x. So we need to increase x. To increase the value of x, what should we decrease? To increase x, we should decrease the value of r. If r is decreased, then x increases. If r is decreased, then x increases. So the separation r must decrease because x is inversely proportional to r. So if r decreases, then x increases. So we must decrease the separation r in order to increase x. 32. What are the definitions of potential difference and electromotive force in terms of energy transfer W and charge Q? So EMF for the potential difference is the work done per unit charge. So whether it is EMF or the potential difference, it is the same. There is a work done per unit charge. So the answer is A. 3. The diagram shows a network consisting of 3 resistors. What is the combined resistance of the network between the terminal X and Y? So what is the combined resistance between X and Y? So this resistor is arranged in series while these two resistors are arranged in parallel. So what is the resistance of the parallel combination? That is 1 by R1 plus 1 by R2 inverse. that is 1 by R is equal to 1 by R1 plus 1 by R2. So after using this equation, we calculate the resistance for the parallel combination plus the series. So the total resistance comes to be 3.15 kilo ohm, that is approximately 3.2 kilo ohm. 34. A resistor dissipates 25 watt of power when there is a potential difference of 4 volt across it. What is the resistance of the resistor? So we need to find resistance. So to find the resistance, we know that power is equal to voltage into current, power is equal to I square R, and power is equal to V square R. And we know the value of power, we know the voltage, we need to find the value of R. So power is equal to V square R, we have to use this equation. So power is equal to V square R, that is R is equal to V square by power. So resistance comes to be 0.64, that is option B. Question number 35. The diagram shows a cell with internal resistance connected in parallel with a fixed resistor and a variable resistor. The resistance of the variable resistor is decreased. So the resistance of the variable resistor is decreased. What happens to the potential difference V across the variable resistor and the current I in the variable resistor? So what happens to the V and I across the variable resistor? So the resistance of the fixed resistor is fixed, but the resistance of the variable resistor decreases. And since the variable resistor resistance decreases, so the total resistance across the parallel combination decreases. Since the total resistance decreases, and we know that resistance is equal to voltage by current, so as the total resistance decreases, resistance is directly proportional to voltage. So as the resistance decreases, voltage decreases. So voltage decreases and resistance is inversely proportional to current. So as the resistance decreases, current increases. Therefore the current increases. Therefore the option is B. 36. A radiative source produces a beam of alpha particle in a vacuum. The average current caused by the alpha particle in the beam is 1.5 × 10⁻89 ampere. That is the value of current. The beam is incident on a metal target. What is the average number of alpha particles hitting the metal target in a time of 3 seconds? So we have given the value of time and we need to find the average number of alpha particle. So what is the average number of alpha particle? That is the number of alpha particle. So to solve this question, we need to know two equations, that is current is equal to charge by time and Q is equal to Ne, where he is the elementary charge. So current is equal to charge by time, so we replace charge by Ne by time. So we know the value of current and we know the value of time, and we need to find the N, that is the number of alpha particles, and E is the elementary charge. So E is 1.6 × 10⁻19 coulomb, and since there is two elementary charge in alpha particle, that is or two protons, so alpha particle contains two protons. So two protons and it contains two protons. So one proton or one electron has a charge of 1.6. One proton or one electron has a charge of 1.6 into 10 to the power minus 19 coulomb. So two proton has a charge of 1.6 into 10 to the power negative 19 into 2. So this is the overall charge of an alpha particle, and after solving we get the value of N as 1.4 into 10 to the power 10 as the number of alpha particles. 37. The charge carriers in a metal wire are free electrons. So free electrons, which statement about the charge of each free electron is correct? So the charge of each free electron is 1.6 into 10 to the power minus 19 coulomb. So the charge is 1.6 into 10 to the power minus 19 coulomb. The magnitude of the charge increases when the potential difference across it increases. No, the magnitude of the charge remains the same. That is, the charge of one electron remains the same. Which statement about the charge of each free electron? It mentions about the each free electron, that is one free electron, and one free electron has a charge of 1.6 into 10 to the power minus 19 coulomb. This is fixed. This cannot be increased or decreased. The magnitude of charge is 0 unless the potential difference, this is not 0. The magnitude of one electron, charge of one electron is the same. The sign and magnitude of charge do not depend on the potential difference of the wire. Yes, this is true. This does not depend on the potential difference. The sign of the charge depends on the potential difference across the wire. This is also wrong. The charge of the wire remains constant, that is, the charge of one electron remains constant, that is 1.6 into 10 to the power minus 19 coulomb. Number 38. Which flavors of quark have charge plus 2 by 3e? So plus 2 by 3e. So up, top and charm. This three quark has a charge of plus 2 by 3e, and down, strange, bottom has a charge of negative 1 by 3e. So for plus 2 by 3e charge, it would be up, top and charm. So charm and top, these have a charge of plus 2 by 3e, while strange and bottom have a charge of negative 1 by 3e. Therefore, the correct statement is A, that is, charm and top has a charge of plus 2 by 3, while strange and bottom has a charge of negative 1 by 3. Therefore, the answer is A. Question number 39. An unstable nucleus of an element decays by emitting an alpha particle or a beta particle. So an unstable nucleus of an element, let us consider as X. So it emits an alpha particle or beta particle. So let us consider it emits an alpha particle. So as it emits an alpha particle, so its proton number decreases by 2, that is 10 becomes 8, and the nucleon number decreases by 4. So 20 becomes 16 after emitting an alpha particle. To form a nucleus of different element, this nucleus is unstable and emits an alpha or a beta particle. The process continues until an isotope of the original element is found. Since the isotope is found, and we know that isotopes are the atoms of the same element with the same number of protons and electrons. Protons and electrons, but different number of neutrons. So isotopes must have different same number of protons and electrons. And since isotope is formed, so the element have to return to 10. That means the proton number have to return to 10. And to return the proton number from 8 to 10, 8 to 10, to return the proton number from 8 to 10, we must lose 2 beta particles. That is, as it emits a beta minus particle, so as it emits a beta minus particle, since beta minus is emitted, so as beta minus is emitted, so as the beta minus is emitted, so proton is produced. That means if 2 beta minus is emitted, so 2 proton is produced. So 2 proton is produced, that means the proton number can return to 10. So 1 alpha particle and 2 beta minus particles are emitted. That means what is the minimum number of possible particles? So the minimum number of possible particles is 3. So the answer is B. In question number 40, a nucleus of carbon 10 decays by beta emission to form a nucleus of boron 10. For this decay process, what is the change to the nucleon and what is the change in the quark composition of the nucleon? So change to the nucleon, so 10 carbon 6 becomes 10 boron 5. So here we can see that there is one less proton that is formed. So boron has one less proton, so proton number is decreased. So proton number is decreased, that means proton is changing to a neutron. So proton is changing to a neutron and proton number is decreased by 1. So proton is changing to a neutron, and proton has a quark composition of up up down, and neutron has a quark composition of up down down. So up and up cancels and down cancels. So as we can see that up quark changes to a down quark. So up quark becomes a down quark. So the answer is B.